Hello everybody, this is Mr. Ray with our second lesson in Unit 1 of Grade 10 Applied Math. We're looking at linear relations in this unit. And in the previous lesson we had an introduction to what linear relations were. Learned a whole bunch of stuff about the independent, dependent variables, what a relation is, and more specifically what a linear relation is. What does that look like in the four forms? The graph, the equation, table of values, most importantly. So you should be able to look at a graph or a table of values or an equation at this point and know that that's a linear relation or it's not. So if you're not quite there, you should probably go back to lesson 1 and practice that or review it again. Okay. Today we're diving a little deeper into the equation of the linear equation, and more specifically, we're going to be talking about the slope of the line and the y-intercept, and how we actually use those two values to create the equation. And this equation, can look differently, but depending on how it's arranged. But if we have y equals, we're going to have two terms, an x term and a constant probably, and we can get the slope from the variable term, and we can get the y-intercept from the constant term. We'll look at that definitely, but that's basically what we're going to be learning. So on the graph, the y-intercept is actually where does our line intersect with the y-axis, and that point will be the y-intercept. So that's going to be something we're looking at. And the slope, there's a few definitions. If you're looking at a graph, the slope basically defines how steep the line is. That's a good way of looking at it initially. But if you go a little bit deeper, we're basically comparing the ratio of the vertical distance that the line changes compared to the horizontal distance. So we look at something called the rise and the run between 2 points and use those values to create the slope. Okay, and when we look at the table of values in the last lesson, we looked at when we examined how is that second column changing. If it's changing consistently by the same amount every time we go down the table, it's going to be a linear. So that difference, how much it's changing by, the correct mathematical terminology would be we're finding the first differences, which is just a fancier way of saying how much is the y value changing each time. Okay. All right, so we're going to be looking at a lot of new concepts, but just to give you a high-level goal, what I want you to be able to do by the end of this lesson is look at a graph of a linear equation, the graph of a linear relation, and be able to create its linear equation, or if you're given the table of values of a linear relation, also create its linear equation from that table. Okay, so if you can do that by the end of this lesson, you basically accomplished what I'm hoping you get. Okay, there's a lot of stuff in the key concepts that we're kind of going to discover a bit more as we do the examples, but I can cover this at a high level just so you know what's coming. Some of it you may already know, some of it will be a little confusing, but you can always go back to this after we do the examples, and it should make a lot more sense at that time. Okay. So any linear relation can be modeled by the equation of the form y equals mx plus b. So the m and the b are actually going to be numbers. Okay. We've got our y, which is our dependent variable, x is independent, and then we're going to have two numbers, one that's multiplying with the x, one that's by itself. Okay, Now the m will actually be the slope of the line, and the b will be the y-intercept. Okay. Now we're not always given the equation in that nice form y equals. It might be a little rearranged, so our job sometimes will be to rearrange the equation so that we get it looking like this. So, and then we can figure out what the slope and the y-intercept are. Okay, and looking from the other side, if I can figure out, if I don't know the equation, but I can figure out what the slope and the y-intercept are, in other words, m and b, I can then use those values to create the equation. And that's what we're going to be doing when we look at a graph or a table of values. We're going to try to find the slope and the y-intercept and then create our equation very quickly from that. Okay. So the slope, and we'll definitely do plenty of examples of this, the slope of a linear relation can be obtained from its graph by selecting any 2 points on the line. Now it's important to choose good points, meaning you would have integer coordinates. Like you don't want to be guessing at the coordinates. You want to know for sure. And we'll talk about that. We want to know that these are good points. We know the exact coordinates. We're not guessing. Okay, and then once we get those 2 points, you're going to see we're going to figure out the rise and the run by drawing a triangle, and then use the rise and the run to create the slope, because the slope is, which is your m value, is equal to the rise divided by the run. Okay, now the run will always be positive. The run is how much should we go left to right. Okay, the rise can be positive or negative depending, am I going up to the right or down to the right? If I'm going up to the right, the rise is positive. If I'm going down to the right, the rise is negative. Okay. Now, if the table of values are constant, and we saw that we did that last lesson, we found that it was a linear relation. All the differences, first differences were constant. That value is actually the slope. So we're going to use that fact when we see a table of values and we calculate the first differences. Well, that's not only used to determine whether the relation is linear or not linear, but if it is linear, we use that number that's the constant change will also be the slope. Okay. And if we're looking at table of values, we can use that first differences to get the slope, and we also find the y-intercept from the table of values. Now you think y-intercept isn't that from the graph? Well, we know that the y-intercept is wherever x equals 0. So if we can find the row in the table where x equals 0, we've also found the y-intercept. So we're going to be doing that as well. Okay, so we're going to do some exercises here. We're going to start off by looking at some equations of linear relations. So we already know they're linear relations. We don't have to figure that out like we did last lesson. What we're going to do is take the equation and then figure out what's the slope of this equation and what's the y-intercept. So this always comes down to we know that the equation, we want it written as y equals mx plus b, and the m and the b will be actual numbers. Once we can figure out what the m is for the equation, that's the slope. Once we can figure out what the b value is, that's the y-intercept. So if I start off with y equals 4x, I can write y equals mx plus b right below it. This is kind of like my template. I'm going to use this to figure out what is m and what is b. So in this case, well, there's my x term. I've got 4x here and mx here. Well, that must mean that m is equal to 4. And I've got a b out here, plus b, but there's nothing here. So what if there's no number there? Well, I could just put a plus 0 here. It would still be the same as 4x plus 0 is the same as 4x. So if you don't see anything there, the value of b is 0. Okay, and now that we've got our two values of m and b, we can now determine that our slope is whatever m is. So our slope of that line is 4, and the y-intercept is equal to 0. Okay, so that's what we're going to do for all these equations. So y equals x plus 9 is our next equation. So if I write y equals mx plus b, and then I kind of compare my variable terms and my constant terms, well, I've got x and mx. So what's the value of m? A lot of people think, oh, since there's no number there, that must be a 0. That's not true if you're multiplying, because 0x would not be the same as x. 1x would be the same as x. So if you don't see a number in front of the x, you can assume it's a 1. Okay, so that means 1x is equal to mx, so m must be 1. M is equal to 1, and in this case we do have a constant term here. It's plus 9. So that must mean that b is equal to positive 9, or just 9. Okay, so that tells us we know the slope is 1 because that's what m is, and the y-intercept is 9. Okay, we'll keep going. So now we've made a small change to this equation. Instead of x plus 9, we got x minus 9. So y equals mx plus b for our template, and this time we have, well, we got the same things we did before, right? So x is the same as 1x, so mx is equal to 1x. That means that m is equal to 1. And now this time, remember the sign, the subtraction sign here, I could consider that to be the sign of the number also. So in this case, the b is equal to negative 9. So whatever the sign is to the left of that constant or the variable term, that if it's negative, that applies to the m or the b value. So in this case, b is negative 9. So that tells us slope is 1, and the y-intercept is negative 9 this time. Okay. Now I'm going to make it slightly more difficult. This time I have y equals 5/2 minus 3x. So I'm hoping you don't fall into a little lull, sense of security that says, oh, the m is always the first number and the b is always the second. That's not true. The m is the number that goes with the x, and the b is the number that's by itself. So what I can do is I can just change the order of these two terms. So I have a term that's 5/2, positive 5/2, and negative 3x. I can just change that to negative 3x plus 5/2. Okay, and now hopefully you can now see, I'm not going to put my template here this time. I can see that the negative 3x, well, that's mx, so m must be negative 3. And our b is 5/2, positive 5/2. Okay, and that tells us now we can go directly from here. Our slope is whatever m is, so that's negative 3. And our y-intercept is whatever b is, so that's positive 5/2. Okay, so make sure you don't just sleepwalk through the question and pick whatever number is the first number and assume that's the slope. It's not always true. It's the slope is the number that's multiplying with x. All right, now the last four, unlike the first ones, the first four, the equations all started y equals. Okay, so it was pretty easy to pull out the m and the b values. These ones, it's a little more difficult because we actually have to rearrange the equation. And we're going to be doing a lot of this in our next unit when we do linear equations, when we solve equations. But for now, let's just, our goal is to get the y by itself. So right now I'm looking at y plus 3 equals 4x. Well, that's not really what I want. I want the y by itself. So you ask yourself, well, what's happening to the y here? Well, we're adding 3. So if I want to undo that, I do the opposite of adding 3. I subtract 3 from both sides of the equation. And when I do that, the minus 3 and the plus 3 cancel each other out. And then I get y equals the 4x that was already there, subtract the 3. Okay, so that's, it can be a little difficult at times, but just try to just think to yourself, I want to get that y all by itself. What do I need to do to undo what's being done to the y right now? Okay, so in this case, we get y equals 4x minus 3. So if I just put my template again once more, you can see that the 4x is mx and negative 3 is b. So it basically says that m is 4 and b is negative 3. So therefore, the slope is 4 and the y-intercept is negative 3. Okay, let's move over to this one. X plus y equals 12. Again, we don't have the y by itself. What do I have to do to both sides? Well, right now I'm adding x to the y, so I have to subtract x from both sides. So when I do that on the left side, the x minus x, they cancel each other out. I get y. Now I could put 12 minus x. That would be totally valid. But I would really like to have my x term first because I'm trying to find the slope and the y-intercept with my m and b values. So because I know I'd like to have the x term first, I put it first. So y equals negative x, and then the 12 was positive, so it's negative x plus 12. If I put my template right below it, I've got negative x and mx, and positive 12 is the same as b. So this one here, okay, what number is in front of the x? Well, I don't see a number, but this is kind of like if it was just x, you assume it's 1x. Now if it's negative x, you can assume that the number is negative 1 in front. You can put it in front if it makes your life easier, and now you can very quickly see that m is equal to negative 1 and b is equal to positive 12. So therefore the slope is whatever m is, so that's negative 1, and the y-intercept is equal to 12. Okay, 2 more to go. This time we have 3x plus 2y equals 6. This one we actually have to do 2 things to this to get the y by itself. So the very first thing we do, don't worry too much about the 2 there. What we want to take care of first is to get rid of any extra terms that are being added or subtracted with the 2y. So I want to get, right now the 3x is being added. So what I want to do is subtract 3x from both sides. So when I do that, I get, well, 3x minus 3x is nothing. I end up with 2y is equal to, now again I want to put my x term first, so negative 3x and then plus 6. Now we're not quite done yet because although I did make it closer to y equals, it's not y equals yet. I have 2y. So you think to yourself, what's happening with the y? I'm multiplying it by 2. So what's the opposite of multiplying by 2 is dividing by 2. So that's what we're going to do, and we're going to do it to all the terms. Okay, so 2y divided by 2 is equal to negative 3x divided by 2 plus 6 divided by 2. And then if we simplify it, we can see, well, those cancel each other out. So y equals negative 3/2 x, and 6 divided by 2 is 3. Okay, so maybe this time I'll go right to the slope and the y-intercept. There's my slope, that's the m value. Slope is equal to negative 3 over 2. and the y-intercept is equal to 3. Okay, so this one was a little tricky. Probably won't be giving you too many like that, but I just want to show you that it could be a little trickier than some of these earlier ones. This one here, we have y divided by 2 is equal to negative 3x plus 5/2. So not quite the way we want. We don't want y divided by 2, we want y. So if I'm dividing by y by 2, what's the opposite of dividing by 2 is multiplying by 2. So what we're going to do is take each of these terms and multiply it by 2. So I get negative 3x multiplied by 2 plus 5/2 divided by 2. Sorry, not multiplied by 2. Okay, so let's clean this up. It looks pretty messy. So these two will cancel each other out. I divide by 2 and then multiply by 2. So that's just y, which is what we want. And then here, we have negative 3x times 2. So we just multiply the two numbers together. That's negative 6. And then we have the x, negative 6x. And then if I multiply these two, I get 10 over 2, which is equal to 5. Okay, so that looks quite a bit different than what we started with. You can see how it's related, though. Everything's been doubled. Okay, and now from that, we can see there's our m value. So that's the slope. And our b value is here. That's positive 5. That's our y-intercept. Okay. So what we've learned to do with this example is take any linear equation. It can be written in any form, and then to pull out the slope and the y-intercept. Okay, and that's going to be important later on for when we graph. If we want to graph a line from its equation, those are the two most important things for us to be able to graph. Okay, now what we're going to do here, example 2, is do exactly the opposite of what we just did. So in example 1, I gave you the equation, and we used that equation to come up with the slope and the y-intercept. Here, I give you the slope and the y-intercept, and we build the equation. Okay, so remember the equation, it's always going to be y equals mx plus b. So m and the b will be the numbers. We actually get the numbers. That's the slope, and the b is the y-intercept. So this is actually quite a bit less. This is not as difficult as the last one, because we just identify, well, where's the slope, where's the y-intercept. They kind of told us that. So wherever it says slope, I know that's m, and the y-intercept will be b. So I start off by writing y equals, and then m in this case was 5, and don't forget the x, because the m goes with the x all the time, and then I add the b value, which is 12. So the equation of that line with slope 5, y-intercept of 12 is y equals 5x plus 12. Okay, let's keep going. Slope, that's our m, y-intercept, that's our b. So the equation is y equals, and then mx, so there's m, 2.5x plus negative 1. Well, I can shorten that to plus negative 1 is the same as minus 1. Okay, so this is going pretty nicely. Our slope is negative 12 for this example. That's our m. Our y-intercept is b. So y equals mx. So that's negative 12x plus 0. So I could put plus 0, but we don't usually, adding 0 to anything doesn't change its value. So in our case, we're just going to leave it as nothing, which nothing here means plus 0. So you could put plus 0. I mean, that's acceptable, but it's kind of pointless because adding 0 doesn't do anything. Okay, this example here, slope is a half, that's m. y-intercept is 0.6, that's b, so therefore y equals mx, so m is 1/2, x plus b, which is 0.6. Okay, this one gets a little interesting. The last two we have slope of 0. So this one's slope of 0, y-intercept of -5, that's b. So it's going to be y equals mx, so that would be 0x plus -5, which is the same as -5. Now, 0 times anything is still 0. So this is kind of like adding 0, which we had up here, which we ignored. So the fact that this will always be equal to 0 means it's not that valuable. It's not important. So I could actually, say that that's 0. So what's 0 minus 5? It's -5. So the simplified equation will be y equals -5. Sorry about that. Y equals -5. That's the equation. Okay. Now this has a slope of 0. So does this. So we'll kind of learn what that means in a couple of lessons. I think next lesson actually. Slope of 0 is like, the table you're working on probably has no slope. If you put a marble on it, it's not going to roll off the end, hopefully. So having a slope of 0 means it's like a table. It's horizontal. It's not going up, it's not going down. It's basically level. Okay? So that's a level, that's a horizontal line. Okay? This one here, both the slope and the y-intercept are 0. So there's m and there's b. So y equals, again, we could do 0x plus 0. And we already know from before, well, 0x is just 0. So 0 plus 0 is still 0. So that looks like it's not much value, but it actually defines a line. Y equals 0. That's basically the x-axis. So that's important. You do have to put a value on this side, even if it is 0. Okay, so that's example 2. Now we get into the interesting part. This is probably the most important part of the lesson. So for each of these, I'm giving you a graph. And what I want you to do is we're going to calculate the slope. We're going to do that by finding the rise and run. So I'll show you how to do that. Now, once we get the rise and run, we figure out the slope. And then we've got our m and our b values just like we had in the last examples, and we use those to create the equation. So I'm just going to zoom in a bit so we can see the graph a little bit better. Okay, so first thing we want to do, well, let's do the easy part. The easy part is finding the y-intercept. So the y-intercept, basically you go, you're looking for where x equals 0. That's always the y-axis right here. So where does our line intersect the y-axis? It's right here. So what's the value of y there? It's each one of these is 1, so that would be y equals 3. So I can go back over here and put my y-intercept as 3. And I know that's going to be my b value. Okay. Now, to get the slope, we actually have to find 2 points on the line. Well, you know what? We've already got one. We got that y-intercept. It's a point on the line. So we want to find another point. So you have to be a little careful with this because not all points are good points. You want to find a point that is going to have integer coordinates. So how do you know that? How do you know if it's got integer? Well, the line will cross at, I call it a crosshairs. So for example, this point here is a good point because it crosses right at, that's y equals 9, x equals 3. So that's a good point. This is a good point. There's a lot of times there's several points you can choose. So it's kind of up to you which points. But don't be picking a point like over here because that's not a good point. You can see this doesn't cross at a nice x value. It looks like it's halfway between, but we don't want to guess. We want to find a good point. We got lots to choose from. So I'm actually going to pick this point here and our y-intercept. Okay, and it really doesn't matter. If you have a good point, you could use it and you'll get the exact same slope value. So you might want to try 2 other points and confirm that. So what I'm going to do is I've chosen these 2 points. I'm going to drop this. I'm going to draw a straight line down till I get to where the other point is. And then I'm going to draw a line horizontally from this point to there. And I've just created a right triangle, right? So the rise and the run, the rise is kind of the vertical change. So this is going to be the rise here. This will be the run. Okay, and what we're looking at, what's the length of that line? How far did we have to go to the right to go from here to here? Well, that's just this length here. Okay, so always do the run first. So the run will always be positive because we're always going left to right. Okay, so that's 1, 2, 3. We went 3 to the right. So the run is 3. Now the rise, you have to be a little careful with the sign of the rise because you could be going up or down as you go left to right. So in this case, I started here and I ended up here because I'm going left to right. And you can always see if the line is going up to the right, well, that's our positive rise. In the example below, we're going down to the right. That should have a negative rise. Okay, so in this case, you can just look at where we started. So we started at y equals 3 for that point, and the y value for this point was 9. So what's the change? The change is 9 minus 3, or you could just count up the squares here. 1, 2, 3, 4, 5, 6. 9 minus 3 is 6, or just count the length of that side there. Okay, so we've got our rise of 6, our run of 3. So the slope is always, remember the slope is rise over run. So 6 over 3, and we can simplify that to 2, and that's our m value. So now we just basically treat this like example 2. We're given the slope and the y-intercept. What's the equation? So hopefully you're pretty good at this now. Y equals, it's going to be mx. So m is 2. 2x plus b is 2x plus 3. So there's our equation for that line. Now we can actually use this equation to find any point along this line we want. I could find the value, what's the point when x is equal to 30? That's going to be 2 times 30 plus 3, that's 63. Okay, so it's a very powerful tool. Okay, let's go to the next graph. So in this graph, again, we're going to do the same process. First thing we do is we find the y-intercept. So that is right here. And we know based on the scale, every box is 1 unit. So the y-intercept is equal to 1. And again, that's our b value. Now we want to find 2 points. So let's reuse the y-intercept. It was a good point. And I see there's just several points. I'm going to pick this point here. So now I'm going to create my little triangle, my right triangle. I'm going to drop this line down till I get to the other point, and then go across. And again, that's going to be a right triangle. So let's do our run. Our run is how far left to right did we go? Well, we went 1, 2. So the run is equal to 2. And if I look at my rise, so now we have to be a little careful with the sign because I started here, because I'm going left to right, started here and ended here. So I'm actually going down. So I might as well put my negative sign in so I don't forget. How far did I go down? Well, that's the length of this. Okay, so you can look at the coordinates and subtract, or you can just add up, 1, 2, 3, 4, 5, 6. So the rise is negative 6. Okay, now we take those 2 pieces of information. Rise is negative 6, and the run is 2. So if we divide these two, rise divided by run, that's negative 6 over 2. which is equal to, and we always want to change this to an integer if we can. Sometimes you can't, but in this case, -6/2 is -3, and that's our slope, our m value. Okay, so now when we create our equation, always start y equals, and then it's mx, m is -3, and then we put our x, and then plus b, that's a +1. Okay, so the most common mistakes I see is getting the sign wrong. Okay, and you can always tell the slope is negative when it goes down to the right, it's positive when it goes up to the right. So you can always do a little check at the end. Do I have the right sign? Yes, I do. It's going down to the right. Okay, last example here. This line's a little not quite as steep as the other two. Okay, so the first thing again, find the y-intercept. It's right there. That has a value of -5. So I put that in here. That's my b value, y-intercept. Now find another point. Well, that looks like a good one there. So I drop that down to where my other point is and draw this across. So this is my run, a horizontal run. How far did I go to the right? 1, 2, 3. And this is how far up or down. Did I go up or down? I went up because I started here, I ended here. So I went up 2. So that's a rise equal to 2. Okay, take those pieces, bring them over here. Rise of 2, run of 3. So the slope is rise over run, 2/3. And we can't do anything with that. We can't even change it to a decimal. So we leave it like that. That's our m. That's our slope. Okay, so now we do our equation. Y equals mx. M is 2/3. X plus b. That's plus -5, which is the same as minus subtracting 5. There's our equation for that line. And you can see the slope of this line was 2/3. Okay, 2/3 is quite a bit less than, well, in terms of the slope. This has a steep slope. This has a steep slope. This is, the 2/3 is smaller than these two numbers. Okay, we're going to talk about that, how steep a line is, in a future lesson. Okay, so like I said, that's a very important skill, is looking at a graph and getting its equation. And like I said, once you've got the equation, you can predict any value along this line exactly and quickly. Okay, so now we're going to look at the table of values. And we're going to calculate the first differences, and these are all linear, so we should see that the first differences are all the same. And once we know what that value is, what the first difference is, that's going to be our slope. And then we're also going to find the y-intercept from the table and then create its linear equation. Okay, so the first thing we're going to do is do the first differences. So again, I'm going to do my comparison between each pair of y values. So, and I'll call it first. This is the first time we're calling it this. First differences. So 5 to 8, that was an increase of 3. Or you could just do it mathematically. 8 minus 5 is +3. 11 minus 8, +3. 14 minus 11, 17 minus 14. And, you know, I've already told you this is linear, so these had better be the same, or something went horribly wrong. Maybe I had a wrong value, but in this case we know. So this tells us that the slope, or the m value, is 3. Okay, and I always prefer if you put plus, even if it's positive, and usually you don't put a plus sign in front, try to put the plus sign or the minus sign so you know the sign. because it's very easy to subtract in the wrong order here and get the incorrect sign. Okay, now how do we get the y-intercept? Well, remember the y-intercept always has an x-coordinate of 0. If I go back to my graphs, all the y-intercepts, okay, this y-intercept, the x-coordinate is 0, okay, because the x equals 0 is basically where the y-axis is. So any y-intercept always has an x-coordinate of 0. Here's this one, and here's this one. Okay, so how can we use that knowledge from the table of values? Well, we go and look for the entry where x is equal to 0. Okay, and whatever the y value is there, well, that's our b value. So our b value is equal to 5, just by finding that x equals 0 entry, and we know our slope from the first differences. So to get the equation, don't forget it's y equals mx plus b, something you should be writing down quite often until you've got it in your head. So y equals m, that's 3x plus b is plus 5. Okay, so there's the equation of that linear relation, and we keep going. So that now that we know how to find the y-intercept, we could actually find that first, right? So there's the y-intercept. So that tells us that b equals 0. And now we can do the first differences. We went from 0 to negative 4, so that's a decrease of 4, etc. So those should be and are all the same value. That tells us that the slope, or the m value, is negative 4. So the equation, therefore, is mx plus b, so that's negative 4x plus b is 0. So I could put plus 0, but again, like we saw before, we probably shouldn't, just to make it as simple as possible. So there's our equation of this linear relation. Okay, do two more. Once you know how to do these ones, it's very, very fast. Okay, so this time, if I go looking for the y-intercept, I can't see, we don't have an entry for x equals 0. So let's put that on the back burner for a second. Let's figure out the first differences. Okay, so I went from 7.5 to 10.5, or 10 minus 2.5, sorry, 10 minus 7.5 plus 2.5 plus 2.5, etc. So we know that is our slope. Okay, so what do we do about the y-intercept? Okay, well, it's important to realize you've already seen the pattern. When I go down to the next entry, I'm always adding 2.5. Okay, what if I go up? So if I go from 5 to 4 to 3, well, that would be the opposite sign, right? I would be subtracting 2.5. So if I kept going, I can use this pattern to create entries for 6 and 7 and 8, but I can also go backwards. I can go and create an entry for x equals 0. And what I would have to do with the y is, instead of adding 2.5, when I go down, I would subtract 2.5. So I would have an entry 0.5. So that's going to be a point on the line. So I can use that calculated point to tell me that this is my b value. Okay, so even if you don't have an entry for x equals 0, you will have to figure out what the first differences are, because that gives you the pattern, and then use that pattern to go back to where x equals 0. So in this case, we had to go back 1, so we had to we had to subtract 2.5 from this entry to get 0.5. So now we can create the equation. Y equals mx, so that would be 2.5x plus b is 5. Okay, last one. So again, we can't see the entry for 0, but we know what we're going to do. Let's do the first differences. So in this case, you got to be careful with the negative signs because at first glance it looks like this is going, it might be going up by 10 because the number is getting bigger, but in reality the number is getting smaller by 10 because they're negatives. So, okay, and you could figure that out by doing a negative 40 minus negative 30, which is negative 40 plus 30. So all of these differences are negative 10. So that tells us that the slope is negative 10, m is negative 10. Okay, so if we want to create, find that missing entry for x equals 0, we actually have to go back 2. So if the pattern is decreasing by 10 going down, it's increasing by 10 going up. So if I have to go up another 2, I'm going to be adding 20 to get this number. So negative 30 plus 20, that's negative 10. So that will be our b value. B equals negative 10. So in this case, it's just a coincidence that the b value and the m value are both the same. It doesn't really mean much. So that's negative 10 from there, x, plus negative 10, which is minus 10. So there's our equation for that linear relation. Okay, so again, we've now learned our second most important skill, developing the equation from a table of values. Okay, we're going to end this lesson off with a word example where we're going to, it's sort of like the one we did on our last lesson, where we start with a word description, and from that word description, we're going to find the different forms. So in this case, let's read let me zoom out. Okay, so at the local ice cream store, Dairy King, no relation to Dairy Queen, a basic sundae with no toppings costs $3. Every topping that is added to the sundae adds an extra 50 cents to the cost. So if you get a plain sundae, no toppings, kind of boring, but that's $3. And every topping we add, it's an extra 50 cents to the price. Okay, what are the independent and dependent variables for calculating the cost of the sundae? Okay, so first of all, we've got the cost in dollars of the sundae. So let's give that a capital C for the variable. And the other thing that's changing is the number of toppings. Okay, so I'm going to say number of toppings, and let's call that T. Now you have to be careful with the T because T's look a lot like plus signs, so it can get confusing. So I'm going to use like an italicized T with a little bit of a curve there so that you can tell the difference. Now, which one is independent, which one's dependent? So we use our little trick about put the phrase depends on. So does the cost of the sundae depend on the number of toppings, or does the number of toppings depend on the cost? And the one that makes most sense is the first one. The cost of the sundae depends on the number of toppings you get. So this will be our dependent. Cost is dependent and number of toppings is independent. And that's going to be important to know how to do a table of values, which we're doing here, how to do the equation, where do these variables go, which side, and also for the graph. Okay, so create a table of values for 0 to 6 toppings. Okay, so I'm going to have my T chart here. So because we know that number of toppings is independent, sort of like our X, the T goes on the left side because independent goes on the left, and the cost is our dependent variable that goes on the right. And they've already said in the question 0 to 6 toppings. 3, 4, 5, 6. Okay. So now we're just use our head based on the description here. How much does it cost for a sundae with no toppings? Well, they told us that straight out. They said that's $3. Okay. And they've also said that every extra topping, it's another 50 cents. So this is pretty straightforward. If I get one topping, it'll be $3.50. $3 for the ice cream and 50 cents for the topping. Oops, I skipped an entry here. So let me go back and fix that. 2, 3, 5, 6. So another 50 cents is $4. $4.50. $5, $5.50, and $6. Okay, so there's what they requested. Now the secondary question, would it make sense to have a row for -1 toppings? So can I go to negative values of t? Well, you have to think of what t represents. T is the number of toppings. Can you get a negative number of toppings? No. You could get no toppings, which is 0, and we've got that. But it makes no sense to have -1 toppings. So sometimes you have to think about what values make sense when you're doing your table. A lot of times negative values don't make sense. Okay, using the table of values from part B, calculate the first differences. So again, we're going to figure out the change in the cost. And that's going to call that first differences. Now, we actually built this table using the fact that we knew that it went up by 50 cents each time. So it's plus 0.5, and this is in terms of dollars, right? Plus $0.5 every time we add another topping. Okay, so that's the first difference. Are these first differences constant? Yes, they are. What does this tell you about the relation? It's a linear relation because of the fact that these are all constant. Okay? So we didn't actually say at the beginning that this was linear, but we were able to determine that by looking at the table of values. Okay, so now that we know it's linear, we're going to create part D. Use the results from C, create an equation to calculate the cost of a sundae. Okay, so normally I'd write down y equals mx plus b. Okay, but we're not using y and x, we're using c instead of y. And we're using t instead of x. So I'm just going to change it so it looks a little different. The m and the b mean the same thing. The m is the slope. The b is the y-intercept. So I want to figure out what those are so I can create my equation. So the fact that I've already got the first differences, we know that the first differences are also the slope. So m is equal to 0.5. Okay. Now, what about the b value? So remember, we did this exercise in the last example. So if I go back to the table of values, I'm looking for where, in this case, where does t equal 0? And that's the very first entry. So whatever that value is, that's my b value. So b is equal to $3. I don't really have to put decimals there, but I'm thinking more in terms of, dollars, the cost. So now that I know these two values, I can replace m with 0.50 and b with 3. So c is equal to 0.5 t plus 3. Okay. By putting the zeros there, it's not going to change the answer. So I'm just going to leave it like that. All right, and now we're actually going to use this equation. we want to find out how much it would cost for a sundae with 17 toppings. That sounds pretty intense. So 17 toppings, the number of toppings is t, so t is equal to 17. And now we plug in, so I'll just write my equation over again here. 0.5t plus 3, and now I'm going to change the t to 17, and then plus 3. So 17 times 0.5, that's 8.5, plus 3, so that's 11.5. So what does that mean? Well, remember the cost is in dollars, so let's put that in a word answer. Therefore, it would cost, so that's dollars, so $11.50 for a sundae with 17 toppings. So that's a pretty big sundae. Okay, so that's, if you look back what we did, we started with a word description of a relation between toppings and the cost of a sundae. We created two meaningful variables, figured out which one was independent, which one's dependent, created a table of values based on just figuring out how much it would cost for this many toppings. We checked the first differences, they were the same, so we know it's linear. Okay, and then we used those first differences because we know for a linear relation, the first difference is the value of m, it's the slope. And we also could figure out what the y-intercept is, or in this case, when does t equal 0? What's the cost when t equals 0? That's 3. Create our equation. And then we can use our equation to find out the exact cost very quickly. And you can imagine if I tried to do this calculation from the table, I'm basically adding another 11 rows. That's a lot of work. Okay, so that's it for today's lesson. Hopefully at this point you're able to, I could give you a graph and you can come up with its equation, or a table of values and you can create its equation. Okay, so next lesson we're going to be looking at properties of slopes. Okay, we're going to look at positive and negative slopes, and what if two lines are parallel? What does that have to do with their slopes? So it'll be a little shorter than the first two lessons. The first two lessons were probably double length lessons. Okay, so thank you for listening and not falling asleep, hopefully, and I'll see you on the next lesson.